Good evening. Today is Thursday, February the 25th. Today in geometry, we looked at two special right triangles which you will be running into or using as long as you are in a mathematics course. So I will share my screen and show you what these two triangles are and how we derive them. So the first triangle we're going to look at is a 30, 60, 90 triangle. And what I will do is I will show you how this triangle is first derived, and then you can maybe understand a little bit about the types of relationships that exist. So you start with an equilateral triangle here. So we'll draw ourselves an equilateral triangle. And we will label this triangle ABC. So this would be angle A, this would be angle B, and this would be angle C. Now, if this is an equilateral triangle, so we'll let each side here be 2. So this is 2, and this is 2, and this is 2 down here. Now, what we'll do is we'll draw the bisector of the top angle here. And if I draw the bisector of the top angle so that this angle and this angle here are congruent, remember this angle down here is going to be 60, and the angle over here on the right at angle B is also 60. So these two triangles, if I let this bottom point here be D, then triangle ADC and BDC are congruent, and that makes these two angles down here at point D right angles. So now if you can visualize, that makes this angle up here 30 because I split a 60 in half. And then if I bisect these two triangles are similar, that means this right here, AD is 1 and DB is 1. So now let's see, if I can erase here, if I can erase the sides like this, then I will go ahead and put the bottom back on there because this right here is still here. So I've erased half of this triangle. So see, I can erase that and I can erase that. I didn't want to erase the vertical line. So I'll put the vertical line back in there. Now see, and then I can erase the 2. So now what you see is I have what's called a 30, 60, 90 triangle. One angle is 30, one angle is 60, and one angle is 90. You see the 2 that was on my original equilateral triangle is still here, and this side is 1. Now if I want to find this side over here, which we'll call H, remember we can use the Pythagorean theorem and say H equals the square root of the hypotenuse squared, which would be 2 squared, minus the side squared, which is 1 squared. So H is equal to the square root of 3. Now, so what I have here is a relationship on a 30, 60, 90 triangle. The thing you notice here, the short side, which is the side opposite the 30, is 1/2 of the hypotenuse. The long side is the short side times the square root of 3. So if I come over here to the left now and draw a kind of a small standard 30, 60, 90 triangle, So I have my right angle here. I have my 60-degree angle here. And I have my 30-degree angle up here at the top. If I can put it in here. So this is my 30-degree angle. This side is 2. This side is 1. And this side is the square root of 3. Okay. Now, so what I can do now, see, if I can erase some of these, erase this number, and erase this number, and erase all this out here. See? Now, so there are 3 different ways that I can give you a problem with this. Like I can come over here and say, okay, the hypotenuse is 20. So the way you think your way through this problem, you say, okay, you look back over here at your reference 30, 60, 90 triangle, where the short side, which is opposite the 30 here, is half the hypotenuse. So that means that makes AD down here to be 10 because it's half the hypotenuse. Now, the long side, once again, is square root of 3 times the short side. So the short side being 10, the long side here would be 10 times the square root of 3. Okay, so that's how you would do a problem where they gave you the hypotenuse. Now, so let's erase this. Once again, if you want to take a second here and look at this, you can pause, but then I'm going to come up here and I'm going to erase my numbers again. Erase the 20, erase this over here, and erase the 10. Now, so now another type of problem, you can say, okay, let's say the short side here is 12. Now, so the short side is 12. I know the short side is 1/2 of the hypotenuse. So that would make the hypotenuse twice 12, which would be 24. And that would make the long side here the square root of 3 times 12, because the long side is the square root of 3 times the short side. So this would be 12 times the square root of 3. Okay, now, so that's the second type of problem where you get the short side. So if we erase this, once again, pause it if you need to and look at that, but then see, we started with the short side there. Okay, so we get rid of this and we get rid of this. Now, the final type of problem you can get is you start with the long side over here. Now, if I say this is 6 times the square root of 3, then I know that this side here is the short side times the square root of 3. So when I'm going from the long side back to the short side, I would divide by the square root of 3. So that would make this side down here 6. And then since the hypotenuse is twice the short side, the hypotenuse would be 12. Now, a similar problem like this, if I erase these numbers, would be you would get a number over here for the long side, but it wouldn't have the square root of 3. Let's say this is just like, let's say this is 5. Now, I know, once again, if I'm going from the long side to the short side, I divide by the square root of 3. So this short side here then would be 5 divided by the square root of 3. And then, of course, the long side here, the hypotenuse is twice the short side, so the hypotenuse would then be 10 divided by the square root of 3. Okay, now you could rationalize these if you wanted to, and down here you would get 5 square root of 3 over 3, and up here would you get 10 square root of 3 over 3. But those are the types of problems that you can get with a 30, 60, 90 triangle. So now I'm going to erase this whole triangle here. because now I'm going to get to the second special triangle, which is a, so I'll come over here and do my text, and I come down here. So the second special triangle is a 45, 45, 90 triangle. And the 45, 45, 90 triangle starts from a square. So if I draw myself a square here, all right, now I know this is a square because I have a right angle here, and each one of these sides is equal. They're congruent, okay? And since they're congruent, remember opposite sides, they're parallel and congruent, then that means all the angles are 90. This one's a 90. Now, what I'm going to do here is I'm going to draw a diagonal from one corner of this down to the other corner here. Now, and what that diagonal does is it splits or it bisects this angle here. So that makes this a 45. And that makes the one up top here a 45 also. So what you have here now is a what's called a 45. Now if I erase, and let's see if I can get this line out, I can get this, and I can get that line out. Now, so you see I have what's left is a 45, 45, 90 right triangle. Now, the two sides are the same here, so this is one and this is one. And if you look at H here, which would be the hypotenuse, H is then using the Pythagorean theorem, is the square root of 1 squared plus 1 squared, which is the square root of 2. So when you have the 45, 45, 90 triangle, so if we come over here and draw it as a sample over here, or our kind of standard 45, 40, so it's going to be an isosceles right triangle, and we come up like this. So this is our right angle here. This is our 45 here. And this is 45 up top. And our sides are the same. They're 1. So 1 here and 1 here. And then the hypotenuse is the square root of 2. Now, so once again, in this case, we only have, if I erase all my extra stuff here, so I get rid of this, I get rid of this, get rid of this, and get rid of this. Now, so here, you can have two types of problems. You can say, okay, if this side right here is 5, then what is this side and what is the hypotenuse? And of course, the two sides are always the same in a 45, 45, 90 triangle. And then remember, the standard says when I go from the side to the hypotenuse, I multiply by the square root of 2. So this would be 5 square root of 2. Okay? Now, if I have a different type of problem, so let's get rid of this and this and this. If I start with the hypotenuse, let's say I get the hypotenuse is 12 times the square root of 2, right? Now, so I know that to go from the side to the hypotenuse, I multiply by the square root of 2. So going backwards, I divide. So that would make this side 12 and this side 12 over here. Now, the only thing that would complicate this is, once again, if I have a situation where the hypotenuse over here is not, let's say the hypotenuse is just a straightforward number like 24, okay? Now, so to get from the side to the hypotenuse, I multiply by the square root of 2. So to go from the hypotenuse backwards, I would reverse that and divide by the square root of 2. So this would be 24 divided by the square root of 2. If you want to rationalize that, you can multiply by square root of 2 over square root of 2, and you would get 2 on the bottom. So you get 12 square root of 2. Because this square root of 2 times square root of 2 on the bottom gives you 2, and 24 over 2 is 12. So that would be 12 square root of 2, and this would be 12 square root of 2. So that's pretty much what we looked at today with these special triangles. And like I said, you should, when you look at these triangles, you know the relationship, because that's what helps you to be able to solve the problems. Now you will find these types of triangles. Now the interesting thing about it is, see, if I come in here, like if you have a triangle, whoops, if I get my straight line here, get my straight line. If I have a triangle that looks like this, for instance, and I tell you that this side here is 20, 24, and this side right here is 12, and it's a right triangle, then you know automatically that it is a 30, 60, 90 triangle, because the short side is half the hypotenuse. So that's the type of thing that you notice as you work through your problems. The relationships, they're always there. And if you have a right triangle and those relationships exist, you know exactly what the angles are without even having to do any calculation. So I'll go ahead and stop this now. Once again, if you have any questions as you're going through your homework, let me know, send me an email. Now what we'll do tomorrow, since I have a tennis match that I have to go to in Bruton with my tennis team, we'll be working on some of the geometry plain and simple problems. So we won't be covering any new information tomorrow. So I will be back with you on Monday. So hope you have a good weekend, and I'll see you then.